All right, so for this video, we're only doing one thing. We're only going to solve for what are the values of x and y. That's all that we're going to solve for. Now I'm going to show you a way to do it in this video, and I'm going to show you another way in class. You can choose either way you want, the way that we do in this video or the way we do in class. It's up to you. It's whatever one you feel most comfortable with. All right, so whichever one you feel better with is the one that you can do. First thing I'm going to do for here is I'm going to label all of our vertices A, B, C, and then I'm going to label this vertex or this point D as well. All right, then I'm going to redraw the other two triangles that we have on the inside. So we have this triangle here, and then we have this triangle here. So I'm going to redraw those two triangles. So the first one I'm going to do is redraw the blue one. I'll redraw it right next to it. And then D will be our right angle. This will be A, this will be C. And then I'll redraw the yellow one off to the side. Angle D is our right angle again. This one's B, and this one's C. All right, so I have these three triangles. I have the overall red one here, and then I have the blue, and I have the purple one. All right, now something that we learned in our last video was if we have a right triangle and we draw an altitude from the right angle, we create three similar triangles. So that means this red triangle is similar to the blue one, and it's similar to the purple one. We know that for a fact. So we're going to draw out our similarity statement now. So it's triangle ABC, so the red triangle, is similar to the blue triangle in that angle C and angle D both correspond to each other. They're both congruent. And angle A is the same in both. So we know A corresponds with A, so I can put triangle, angle A corresponds with angle A, and then I know angle C corresponds with angle D, so I can put D last. So that means this angle C must correspond to this angle B. All right, and then for the purple one, we can have triangle similar to triangle, same thing. I know that angle D corresponds to angle C because they're both right angles. So I know D once again has to go last. In this case, angle B is the same as angle B, so I know that they correspond. So since B was second, B would have to go first here. And then that means C must correspond with angle A. So it's similar to triangle CBD. Right, now after that, I'm going to then go ahead and fill in all the sides that we have for a triangle. So I know this side is 16 total because 12 plus 4. I have CD is equal to Y, so I can fill in Y here. AC is equal to X, so I can fill in X here. And then AD is equal to 4, so I can fill in 4 here. And then go into the purple triangle. I know that BD is equal to 12, so I can fill in 12. And I know CD is equal to Y, so I can fill in Y. All right, so I'm just going to erase some of what I have here. So that way we can see these numbers on this triangle a little bit clearer. So let me just redraw this as red. And see. Now if you notice, only one of our triangles has all three side measurements, and that's our blue one. We have X, Y, and 4 for this blue triangle. The other two triangles, we only have 2 of our sides. So we only have 16 and X for the red one, and then we only have 12 and Y for the blue one. So what this is showing us is that we're going to have to use this blue triangle to solve for and the red one to solve for a missing side, and then we're going to have to use the blue triangle again to solve for the other missing side for purple. All right, so we're going to have to use blue to create similarity or to create proportions with the other two triangles because blue is the only one we have all three sides. And if you notice, our red triangle has the variable X in it, so that means we're going to use the red and blue to solve for X. And then our blue triangle, or our purple triangle, has Y in it. So that means that we're going to use the purple triangle to solve for Y. So the first one we're going to solve for is we're going to solve for X. So our 16, this hypotenuse, AB, corresponds with the blue triangle, CA. Because that's our hypotenuse of the blue triangle, CA. And if you notice, AB is written first and second. AC is also written first and second, so we know that they correspond. Then I'm going to create a proportion. So it's going to be equal to. So now I'm picking, I want to solve for X. It's the only variable I need to solve for from the red triangle. So I'm going to pick that side AC. And what side does AC correspond with the blue one? It's going to correspond with AD because AC is first and third. AD is first and third. It's going to correspond with this AD here. Now, when we do this, if you notice, what happens when we fill in our numbers? We get 16 over X is equal to x over 4. Right? And this is something that we've learned already in another one of the videos that we can solve, but we only have one variable. If we tried to do anything with this CD here and our red triangle, we would have an x and y, and we wouldn't be able to solve it as is. So now we can go ahead and solve for this. So we will cross multiply, and we get 4 times 16, or 64, and we get x times x, or x squared. Right? Then we'll take the square root of each side. And x is equal to, remember, I want you guys to get in the habit of doing everything correct algebraically, so it's plus or minus 8. Then you ask yourself, does negative 8 work? No, because we're dealing with a side, so we can then cross out that negative 8, and x is only equal to 8. Okay, so I can then cross this out over here, and I can put 8 there. All right, and if you notice, if x is 8 here, and 4, and this is 4, this is 1/2 of 8. And then if this was 16 and this is 8, it's also 1/2 of 16. So it works out nicely with our ratios. Now, solving for this 8 with the blue triangle didn't really help me with y as is, because I don't know what my hypotenuse is over here anyway. So I can go ahead and I can create a ratio, and I don't know what this side length is, BC, to correspond with this y. So I have to redo a whole nother ratio now with the blue triangle with the purple. All right, so now the two sides that we know here, or we know this side and this side correspond, and we know this side and this side correspond, so we're just going to create a ratio, or a proportion. So our y, CD, that's what we want to solve for. I'm sorry, I'll put that in blue since it's the blue triangle. So it's CD, and in the purple triangle, that corresponds with this side over here, BD. And then the only other side I know in this purple triangle is this side down here, so I got to make sure that I have it over top of CD. So what corresponds with CD in the blue triangle? Well, CD's first and third, AD's first and third, so I know AD has to correspond. Then I fill in the information. CD was equal to y. BD was equal to 12, so it's y over 12 is equal to. AD is equal to 4, and CD is equal to y. So same thing that we have here, we only have one. As we did over here, we only have one unknown, y's, and when we cross multiply them, it's going to be nice because we're going to go ahead and get y squared. We already solved some problems like this as well. So we get y squared is equal to, and now this one is 48. Right? Then from here, we will take the square root of each side. So y is equal to plus or minus the square root of 48. So you'll ask yourself, can we have a negative square root of 48? So that answer is no, so we'll cross that out. Y is equal to the square root of 48. Right? Then from here, we're going to see, can this simplify? So do any perfect squares multiply evenly into 48? Yes, 16 does. So we can rewrite this as y is equal to 16 times 3. And then we take the square root of 16 is 4. So y is equal to 4 root 3. Right? You will have to be able to simplify your radicals. Right? That's it for this question. That's it for this section. If when I show you in class another way, if you find that way easier, then that's fine, and you can go straight to that. The other class won't draw out these triangles. It kind of just goes ahead and jumps straight to these two proportions, but you just have to remember a few different things for it.